My dear students, welcome back to our channel. In this video, I will be explaining the Bachelor of Computer Applications 4th semester subject Software Engineering as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 3, the important short question is: what is data modeling? Data modeling is the process of organizing data in a way that is easy to understand and use. It shows how data is stored, connected, and used in a system like a map of your data. It helps software engineers know what data is needed, where it comes from, and how different parts of data are related. Example: imagine a college database. You have students' name, roll no, course. Teacher's name, subject. Classes, time, room. Data modeling will show how one student attends many classes. One teacher teaches many students. Why it's useful? It helps to build software that handles data smoothly and correctly. Types of data models: 1. Conceptual, big picture. 2. Logical, detailed structure. 3. Physical, actual database design. Easy tip: think of it like blueprints for data before building a house database. Next important short question is: 2. What is inter-organizational communication? Interorganizational communication means sharing information between two or more different organizations to work together smoothly. It is used when companies collaborate on projects, share data, or use software systems that need to talk to each other. Example: imagine an online shopping website like Amazon working with a courier company like Blue Dart. Amazon sends delivery details to Blue Dart. Blue Dart updates the delivery status back to Amazon. This is interorganizational communication. Both systems are talking to each other. Why it's important? Helps in faster decision-making. Improves teamwork between companies. Reduces errors and delays. In software engineering, we use tools like APIs, web services, or AD, electronic data interchange, for this communication. Easy tip: think of it like two friends chatting over WhatsApp to plan something. They need to stay connected and share the right info. Next important short question is: 3. Object-oriented analysis. Object-oriented analysis, OA, is a method used in software engineering to study and understand a system by thinking in terms of objects, just like in real life. In OA, we focus on what the system should do, using classes and objects. Example: imagine we are building a library management system. We identify objects like book, title, author, ISBN. Member, name, ID, contact. Librarian, name, employee ID. These objects have attributes, details, and behaviors, actions, like a member can borrow a book. A librarian can add or remove books. Why use OA? It makes the system more clear and organized. Easy to move to coding in object-oriented languages like Java or Python. Easy tip: think of OA like creating characters for a movie. Each has a role, actions, and properties. It helps make software design more realistic and reusable. Next, Unit 3. Long questions. First important long question is: explain different architecture styles. In software engineering, architecture styles are like design blueprints that show how different parts of a software system are organized and how they communicate. Let's look at some common architecture styles in a simple way. 1. Layered architecture. System is divided into layers like a cake. Each layer has a specific role and talks only to the layer next to it. Example: UI layer, user interface. Business logic layer. Data layer, database. Used in banking apps, web applications. 2. Client-server architecture. Two main parts: client asks for data and server provides data. Example: when you use Google, your browser is the client and Google's server sends the results. Used in websites, email systems. 3. Peer-to-peer, P2P architecture. Every system, peer, acts as both client and server. Example: file sharing apps like BitTorrent. Used in music sharing, blockchain. 4. Event-driven architecture. Components talk to each other using events. One part sends a message, event, and others respond to it. Example: online shopping app. When you place an order, many actions happen like payment, email notification, etc. Used in e-commerce, real-time apps. 5. Microservices architecture. Application is broken into small services, each doing one job. All services work together but can be built and updated separately. Example: Netflix login, search, and video play are all different microservices. Used in large, complex systems. Easy tip to remember. Layered is equal to cake. Client-server is equal to question and answer. P2P is equal to sharing among friends. Event-driven is equal to doorbell system. Microservices is equal to teamwork of small experts. These styles help developers choose the best structure for a software system based on its needs. Next important long question is: to explain about the object-oriented architecture. Object-oriented architecture is a way of designing software where the system is made up of objects, just like in real life. Each object has its own data and can perform actions. This architecture is based on object-oriented programming, OOP, principles like encapsulation, inheritance, polymorphism, and abstraction. Key concepts. 1. Object: a real-world thing, like a car, student, or book. It has attributes, data, example, a car has color, brand. Methods, actions, example, a car can start, stop. 2. Class: a blueprint to create objects. Example, a student class can be used to create many students like Ravi, Priya, etc. Example: let's build a library management system. Classes: objects. Book, title, author, ISBN. Member, name, ID, contact. Librarian, name, employee ID. Each object has its own tasks. Book can be issued or returned. Member can borrow books. Librarian can remove books. All these objects work together to make the software run smoothly. Benefits: modular, easy to build and test each class separately. Reusable, use the same class to create many objects. Maintainable, easy to update one part without affecting the rest. Real-world modeling matches the way we think in real life. Where it is used: games, e.g. characters, scores. Web apps, e.g. user accounts, products. Desktop software, e.g. MS Word has tools like font, color as objects. Easy tip to remember. Think of object-oriented architecture like a team of workers. Each one, object, knows their job and works with others to complete the task. Together, they make the system run perfectly. So, OOA helps create clear, clean, and organized software systems. Next important long question is: 3. Describe the cloud computing architecture style. Cloud computing architecture is a way of designing software and IT systems where everything, data, apps, and services, runs on the internet, cloud, instead of your local computer. It has two main parts. 1. Front-end, what the user sees, web browser, app. 2. Back-end, where the actual work happens, servers, storage, databases. Main components of cloud architecture. 1. Client devices. Laptops, phones, or browsers that access cloud services. Example, you open Google Drive on your phone. 2. Cloud services. Applications and tools delivered over the internet. Example, Google Docs, YouTube. 3. Cloud storage. Stores all your files, videos, and data online. Example, Dropbox, Google Drive. 4. Cloud servers. Powerful computers that do all the heavy tasks behind the scenes. Example, Amazon Web Services, AWS, Microsoft Azure. 5. Internet. Connects everything together. Example. Imagine you are watching a movie on Netflix. You open Netflix app, front-end. Netflix fetches the movie from its cloud servers, backend. The movie plays smoothly on your device using internet, that's cloud computing in action. Types of cloud services, easy to remember as SPI. SaaS, software as a service, ready-to-use apps. Example, Gmail, Zoom. PaaS, platform as a service, tools to build apps. Example, Google App Engine. IaaS, infrastructure as a service, storage and servers. Example, Amazon EC2. Benefits. Low cost, no need to buy servers. Scalable, easily increase storage or power. Accessible, use from anywhere, anytime. Safe, data is backed up on the cloud. Easy tip to remember. Cloud computing is like renting a house instead of building one. You get all the services, but you don't have to manage the building, hardware. It's the future of software, simple, smart, and online. Next important long question is 4. Describe architectural design principles. Architectural design principles are the basic rules or guidelines used by software engineers to create well-structured, reliable, and scalable software systems. These principles help make software easy to build, understand, and maintain. Let's understand each principle in simple words with examples. 1. Modularity. Break the system into small parts, modules. Each part should do one job. Example, in a shopping app, separate modules for login, search, and payment. 2. Abstraction. Hide unnecessary details and show only what is needed. Example, you use a mobile app, but don't see the code behind it. 3. Separation of concerns. Each part of the system should focus on one task only. Example, UI handles the screen, while the database handles data. 4. Reusability. Write code that can be used again in other projects or modules. Example, a login module can be reused in different apps. 5. Scalability. Design so the system can handle more users or data in the future. Example, Amazon handles millions of users daily, thanks to scalable design. 6. Maintainability. The software should be easy to fix, update, or improve. Example, if there's a bug in the payment module, you can fix it without touching the whole app. 7. Performance efficiency. Software should run fast and smoothly without using too many resources. Example, Google Search gives results quickly, even with billions of users. 8. Security. Protect the system from unauthorized access or attacks. Example, passwords are encrypted and not visible to hackers. Easy tip to remember. Use the word smart maps to recall. Scalability, modularity, abstraction, reusability, time performance, maintainability, access, security, parts, separation, simplicity. These principles help developers build strong, flexible, and future-ready software systems. Next important long question is: 5. Differentiate between top-down structured and object-oriented analysis. In software engineering, there are two popular ways to understand and design systems. Top-down structured analysis, TDSA. Object-oriented analysis, OA. Let's compare both in simple words with examples. 1. Approach. TDSA breaks the system from top to bottom, step by step. Like breaking a big problem into small tasks. OA focuses on real-world objects in the system. Like identifying people and things and their actions. 2. Focus. TDSA focuses on functions processes, what the system does. OA focuses on objects and classes, who does the work. 3. Design style. TDSA uses DFDs, data flow diagrams, flowcharts. OA uses UML diagrams like class diagram, object diagram. 4. Data and functions. TDSA keeps data and functions separate. OA combines data and functions inside objects. 5. Example. Let's design a school management system. TDSA. Start with main functions like manage students, manage fees. Then break into subfunctions like add student, edit student, etc. OA. Identify objects. Student name, roll no, marks. Teacher name, subject. Class, room no, time. Then define actions. Student can enroll, view marks. 6. Reusability. TDSA, less reusable. Functions are fixed. OA, highly reusable. Classes and objects can be reused in other projects. Summary table. Feature, TDSA, OA. Focus, functions, objects. Data and logic, separate, combined. Diagrams, DFD, flowcharts, UML, class, object diagrams. Reusability, less, more. Approach, top-down, real-world mapping. Easy tip. TDSA is like writing a step-by-step recipe, while OA is like identifying ingredients, objects, and what each one does. Both are useful, but OA is preferred for modern, large-scale software. Next important long question is: 6. Write short note on logical and static modeling. What is logical modeling? Logical modeling shows how the system should work, but without worrying about how it will be built. It focuses on what needs to be done, not how. It represents the flow of data, relationships, and rules in a system. Example. In a college system, a logical model will show: a student is enrolled in a course. A teacher teaches a course. But it won't say how the database is actually created. Tools used: entity relationship diagrams, ERD. Class diagrams in object-oriented design. What is static modeling? Static modeling shows the structure of the system, the parts, objects, classes, and how they are connected. It doesn't focus on actions or behavior. It represents the objects, attributes, and relationships in the system like a blueprint. Example. In a shopping app, static modeling shows: a customer has a name, email. An order has items, price. A customer places an order. Tools used. Class diagrams. Object diagrams. Component diagrams. Difference between logical and static modeling. Feature, logical modeling, static modeling. Focus, what system should do, how system is structured. Level, conceptual, structural. Shows entities, rules, data flow, objects, classes, relationships. Example, tool ERD-UML class diagram. Easy tip to remember. Logical modeling is equal to what should happen? Like a story. Static modeling is equal to what is there? Like a blueprint. Both are important for designing clear and complete software systems. Next important long question is 7. Discuss how to identify class relationships. How to identify class relationships. In object-oriented analysis, OA, understanding how classes relate to each other is very important. These relationships show how objects work together in a system. Here's how to identify class relationships with simple steps and examples. Types of class relationships. 1. Association. A simple connection where one class uses or interacts with another. Example, a teacher teaches many students. They are linked but independent. 2. Aggregation, whole-part relationship. One class is a part of another but can exist separately. Example, a library has many books. Books can exist even if the library is closed. 3. Composition, strong whole part. One class is made up of other parts that cannot exist alone. Example, a house has rooms. If the house is destroyed, rooms don't exist separately. 4. Inheritance, generalization. One class inherits properties and behaviors from another. Example, car and bike inherit from a general class vehicle. Steps to identify relationships. 1. Understand the problem domain. Read the requirements carefully to find real-world entities. 2. Identify the classes. Find main objects like student, teacher, library. 3. Look for interactions. Ask questions like who uses whom. Who owns what? Example, does a student borrow a book? Then student and book have association. 4. Check if objects can exist independently. Helps decide if it's aggregation or composition. 5. Find common features. Look for similar properties or actions to find inheritance. Example, in a car rental system. Customer rents a car, association. Car has engine, composition, engine cannot exist separately. Sedan and SUV inherit from car, inheritance. Easy tip to remember. Association is equal to friends who know each other. Aggregation is equal to a team where players can play elsewhere. Composition is equal to a body and its organs, inseparable. Inheritance is equal to family traits passed from parents to children. Knowing these helps build clear and strong software designs.